Hi, my name is Manish Gupta, and in this video, I'll talk about a system that helps to mine answers to questions from a pool of images, also called as the retrieval-based visual question answering. Okay, so what is visual question answering? Well, visual question answering is a problem where you have an image and a text-based question, and you want to come up with a text-based answer, right? In this particular case, this problem setting is slightly different, and it's called as retrieval-based visual question answering. In fact, this is a problem setting that we have introduced in this paper, which is going to be presented at IJCAI 2023. So what is this setting all about? So here the idea is that you have a question, but rather than having one image, you actually have a set of n different images. In fact, you have a large image collection. Right? And then the idea is that the system must come up with or generate an answer A, but then it must figure out which of those images from the large collection it can leverage. Okay. Here is an example. Do the rose and sunflower share the same color? And then, while roses can be of different colors and so on, you must answer the question based on the collection of images which is supplied to you. Here are 9 images which are supplied to you. And therefore, the system must first understand that this image contains roses, this one contains sunflower, and these are the two it must use so as to be able to generate the right answer that no, the rose and sunflower do not share the same color. So remember, the setting is also very different from retrieval augmented generation, right? So here it's not like you really need the images just to come up with a very, come up with a better answer for the text question. Here, the idea is that the text question needs to be answered in the context of the images in the image collection. Although it also has similar things like a retriever and a generator, but then the idea is that it's not retrieval augmented generation, it's retrieval based generation. Okay. So the architecture here essentially has three main parts: relevance encoder, retriever, and then generator. Okay. So given a question, text question, and a bunch of images in the image collection, you actually encode the text question and the images using a relevance encoder. Right. So you actually encode the text question and each of the images in the collection individually, independently. Right. So the relevance encoder looks like this. You basically take a BERT model and then encode the question text part of it. You take faster RCNN and essentially encode the images using the objects extracted from using faster RCNN. This followed by 3 transformer layers, and then take the CLS token, apply the MLP layer, and that gives you the relevance score. So it tells you how relevant the particular image is to be able to answer the question. Now, using basically here, the relevance encoder, the transformer layers here essentially are actually pre-trained using the MS COCO data. So MS COCO is a very popular image captioning data. So you essentially pre-train it using MS COCO data using two loss functions, pre-training loss functions, the MLM mass language modeling loss function and the ITM, the image text matching loss function, where you would basically, the idea is to essentially predict a 1 if the image and the text are relevant to each other, or predict a 0 if they're not relevant to each other. Okay. So after the pre-training for the relevance encoder is done, when you train this model for retrieval-based visual question answering, you essentially fine-tune the pre-trained relevance encoder. And the way you fine-tune it is using question image relevance learning, where, of course, in the training part, you essentially know if this particular image is relevant or not, and if this image is not relevant, right? So that's what you do. And the way you do this is by minimizing the binary cross entropy loss. Okay. Now, after the relevance encoding is done here, individually for each of the images in the image collection, this is followed by the retriever, which basically takes top K images by their relevance score as computed by the relevance encoders. Okay. Now, the top K matching images are supplied as additional context input to the BART encoder decoder kind of a model. Okay. So as you see here, our MI-BART model, multi-image BART model, actually takes 12 layers of encoder, 12 layers of decoder, and essentially tries to compute the output to the question or the answer to the question. As you see, the input is the question, and also the input is top K images, which go top K retrieved images with the highest retrieval score, which go as additional input, additional context, so as to come up with a very accurate answer. Now, how does the model perform, right? So this model is evaluated on 2 different data sets, a new data set that we create specifically for this task called as the retrieval-VQA visual question answering data set. It is derived from the popular visual genome data set. Here are the statistics for this new data set. there are questions across different categories. So the answers could be color, shape, count, object attributes, or relation-based answers, right? Now the answers could be binary or open-ended. So binary answers are just yes, no kind of answers, and open-ended answers basically are rather, those question answers are of this kind. What else eats same thing as brown horse? So you must predict, hey, what is the ID and what is the answer? And here the answer is sheep, right? So it's not yes or no. Okay. We also experiment with the popular WebQA dataset, which also is very similar, but then it is much smaller compared to this new retrieval VQA dataset. Okay. In fact, the RetVQA dataset is the largest dataset which needs at least 2 images to be able to answer these kinds of questions. Okay, the accuracy is measured using two different metrics. The accurate, metric called as accuracy, and the other is fluency. So the accuracy metric really here captures whether the correct answer is present in the generated answer by the system or not. While fluency metric is actually computed in a very interesting manner. So if your system generated some answer and then you have a ground truth answer, what is the probability of the generated answer given the ground truth answer as input to a BART model? Okay. So the way fluency is computed is that, what is the probability of the generated answer on the decoder output? If you basically give the ground truth answer as input to a BART model, it's sort of called as the BART score. And then while computing fluency, we also normalize this BART score, where the denominator essentially is that if you give the ground truth, answer as input, and what is the probability that the BART model gives to the ground truth answer itself at the output, at the decoder output. Okay. So what is fluency? Fluency is basically the ratio of probability of ground truth of probability of generated answer given the ground truth answer, divided by the probability of the ground truth answer given the ground truth answer itself, as computed by the BART model. Okay, so here is how the results look like on two different data sets, RetVQA and WebQA, right? And then results are shown with Oracle retrieved images, Oracle evidence images versus retrieved images. So Oracle images versus retrieved images. Okay. Well, you see, of course, the MI-BART, the proposed model results here, and you see that the proposed model does really well across different settings. So essentially with Oracle images as well as with retrieved images across different metrics, accuracy and fluency both, right? So you also see that it performs better compared to popularity-based baseline. So you could basically just say, hey, let me actually just capitalize on the bias if it may exist in the data set. So let me basically just predict yes is the answer if that's the most popular. So we have a global popularity, per category popularity also. So maybe the popular answer in the color category is different, and the popular answer in the count category is different, and so on. So basically leverage all of those popularity values. Right. So it's also better than other baseline approaches, which basically just look at question only kind of a baseline, or image only kind of a baseline, or rather aggregate VQA kind of a baseline, where we essentially pass the retrieved image one by one and try to check what is the overall aggregate answer that the model predicts. Right. So we also essentially experimented with a very interesting baseline called as image stitch MI-BART, where the idea is that the retriever remains the same. We retrieve essentially a bunch of images, and then we essentially stitch all of those together and then give it to the BART model for further processing. Now, remember, when we basically do our MI-BART proposed model, we are sort of, again, giving multiple images as input to MI-BART, but we are sort of concatenating the evidence in the embeddings kind of a way. While when we do image stitch MI-BART, well, the idea is that you have retrieved relevant images, you just concatenate them in the image space itself and then give them as input. Okay. So that's that. So now what you see here is a example about how the model performs, for a question, what else eats same thing as brown horse? And there's a whole bunch of image collection which is supplied, and it nicely predicts this particular image as relevant and this image is relevant. There's the horse here, it's eating grass, and there's sheep here eating grass. And ground truth answer, of course, is sheep eats same thing as brown horse. Compared to another multimodal generative model, VLP, which predicts zebra eats same thing as brown horse, this model is more accurate. It can actually come up with results like sheep eats same thing as brown horse. Okay. Now, at the bottom, what you see here is basically attention visualization of a model. So when you basically give this question as input and you also give the context, these retrieved images as input, top to retrieve images, what you observe here is that, yes, when it tries to come up with the answer here, sheep eats, so the top thing is the question, and here on each of those rows here is essentially the answer. So what basically has a very high attention score on sheep, which makes sense, and then eats, same thing as a brown horse also. So the diagonal is also very heavy, which makes sense from a text-based attention perspective, question to answer attention. Okay. What you also see is image attention while generating each word in the answer. So, when you see sheep here, it has a very good attention on the sheep part of the second image of this image in retrieved image. And also, it has a very good attention on the horse, basically saying that the sheep and the horse are linked when you're trying to generate the word sheep. Okay. And then, eats basically has a very good high attention on the eating part of this thing. And again, when you basically look at the horse, it has a very high attention on horse as expected. Okay. So in overall, in this video, I talked about this new problem setting called as retrieval-based visual question answering. And remember, this is a different problem setting from retrieval augmented generation, right? While in retrieval augmented generation, the images essentially add value in terms of trying to give extra evidence so as to answer the question appropriately. Here in retrieval-based visual question answering, the retrieved images essentially are the most relevant images from the image collection, and they are a must to be able to answer the question accurately. Okay. We proposed in this video, I basically showed how we proposed a unified multi-image BART model to answer the question from the retrieved images using our relevance encoder. Right. We leveraged BERT model for encoding the text and also the fast RCNN model to encode the images. And then we had transformer layers which were pre-trained using image captioning kind of MS COCO data and fine-tuned using our own data set. We showed how we achieved an accuracy of 76.5% and fluency of 79.3% on the newly proposed RetVQA dataset. And we also showed that our RetVQA model, our MI-BART model actually outperformed the state of the art on an existing WebQA dataset by massive amounts, 4.9% and 11.8% on accuracy and fluency respectively. Hope you liked the video. Thank you for watching. Connect with me on my LinkedIn or look at my research on my homepage. Thank you.